Hey, Brian Beeler here, and thanks for joining the podcast. We've got a great guest today with AWS. We're going to talk all things snow and wherever else we go with this thing. But data transport is a big problem or issue or challenge, right? As these workloads go to the cloud, and how companies get their data from point A to point B is one of those things that Snow helps resolve. And Snow just went to space, so we've got all sorts of stuff to talk about. Wayne, thanks for coming in and doing this with us.
Brian, it's my pleasure. Thanks for inviting me.
So set it up for the audience that doesn't know you. What is your role at AWS? And I think based on your bio, you've been there almost since the jump. If that's accurate, let me know.
I have I've been with AWS for Amazon for almost 10 years. It'll be 10 years in September. So I'm coming up on my what we call red anniversary, and I'm pretty excited about that. Within the company, my responsibility as one of the vice presidents at AWS, I'm responsible for a suite of our storage products, our edge compute and edge storage products, and our data protection and data movement services.
And so the Snow devices fit squarely in that data movement
Well,
kind
interesting. Well, let's talk about that, Brian, because that is a true story. The truth is that as part of our entire edge continuum, and part of that, as you mentioned at the beginning of this, is taking a snow cone to space, which extends the edge of the cloud to the furthest reaches so far. The Snow product is part of our data movement capabilities, but more so today, it is part of our edge compute, edge storage, and edge networking capabilities.
Interesting. So I want to tear into that. Before we do that, let's take one step backwards and kind of reset why these devices exist, where they came into play. I think the first time I saw one in practical use was, oh gosh, several years ago. It was some HPC guys were doing a research project with drones out in the field, and then they wanted to get that data back to the cloud to run their analysis or whatever they're doing. But they were creating not massive amounts, but pretty good amounts, a couple terabytes still out at the edge, and it would take too long, too onerous to get all that data back up to their instances. So they had the USB hard drive, which I think was the first product, and copying the data over, shipping it with its e-ink FedEx label or whatever, and then you guys ingest it. But maybe just reset for us how this started and what the problems were you were trying to solve.
Yeah, so there is a journey story, if you would, for this service, and what we did last month by putting a snow cone in space is more at the current end of that journey story as we continue. But when we first started, there's an old adage, the fastest network is a station wagon full of disk drives. And
you
so
forgot the graybeards that go with it.
I have them. So the truth of the matter is that in the earlier days, we'll go back roughly 2014, 2015 or so. Customers were quickly beginning to move their data to AWS, to S3, and to Glacier specifically. And the networks that they had supporting their, the volume of data they needed to move simply were not there. If folks had a 10 gig or 100 meg connection to the internet, that was pretty healthy. And though that worked for several gigabytes of data, maybe even hundreds of gigabytes of data, it didn't work for terabytes and petabytes, and as we see now, believe it or not, exabytes of information. Zettabytes are coming soon. Exabytes of information that people needed to move up to the cloud. So we created our service called Snowball, which we refer to today as the Snow family of products. And it was, for all intent and purpose, as you said, it was a very rugged and deployable storage device that customers could order off our website. It has an e-ink label on it, which gets assigned their mailing address as they provision the device on our console. And that device arrives at their facility, at their data center. It's Ethernet based. They plug it in. They run data movement, if you would process or program, and that would move their data from whatever it was on at the time. Could have been a file or an object store. Today it can be tape, virtual or physical. And when they were done filling it up, they would send it back to us, and then we would take it and ingest that into their, for instance, S3 bucket. And now their data is there. Now, that was the beginning. And as we've evolved, customers would tell us, hey, you know, I'm moving all this data onto your device, but we'd like to do a little processing on that data before we send it up. We'd like to run some analysis or some algorithm to either ascertain some information, do some analytics, or potentially to filter some of the data that we don't want to go up into the cloud for whatever reason. So we extended the capability of this storage device into being a storage and compute device. And as customers started to use those capabilities, it's like the old story of if you give a mouse a cookie, they want a glass of milk. Customers came back and said, we'd like to do more. We like this model. This works. So here we are in 2022. And we've really moved the service from being a data transfer service into being a service which customers can use to collect data wherever they happen to be. In the most recent case, you know, on the space station, to process that data. And processing could mean a bunch of different things. In the case of what we did recently, it was running machine learning. If you would, we're running visualization analytics on the device. And as pictures were being taken, those pictures were being classified, they were being analyzed, and the analysis was then what could be transferred back to Earth, back to Mission Central, in order for them to take a look at that data and say, you know, interesting, let's keep doing more, let's do something different. So the ability to collect.
Is that happening on your device? Because the genesis story of a hard drive with an Ethernet port on it, making it sort of NASy to collect data and then ship it off, is a lot different than, you know, having enough compute, maybe GPU or whatever, on a system to be able to run inferencing like what you're talking about, right?
That's exactly correct. So we're on generation 3, if you would, of our Snowball Edge device, and we're on generation 2 of our Snowcone device. And for each of those generations, like with many devices, based on what customers want to run, we've increased the storage capacity, the networking capability, the compute capacity, and in the case of Snowball Edge, customers do have the ability to order the device using GPU capability. So it is a full-fledged, you know, you can look at it in many ways as a full-fledged set of EC2 instances, some of them with GPU capability, running in what we refer to as a denied, disconnected, limited, or intermittent environment. When it comes
Interesting. So, I mean, does it, it must be, though, that once customers get this thing, especially with some of the advanced capabilities like GPU, and start using it, they're like, this thing's kind of nifty. Maybe we should use it more, or maybe it should hang out longer. Are you seeing cycle times of when these go out to customers versus when you get them back in? Is that changed at all over time?
It has dramatically, actually. So if you think about a data migration order from years ago, you know, the device would be ordered to be delivered within, say, you know, a week, 2 weeks, maybe a month. The device would come back, and that would work really well for customers. When customers started using the device for collecting, analyzing, and making decisions in real time in the field with these devices, you know, we start to see those timelines extend quite a bit. It's not unusual that a month is a very short job. That 3 months is an average job. And in some cases where these devices are used in environments that are fully denied or fully disconnected, those devices can stay in the field for well over a year. Some as long as 3 years.
Well, how does that start to bridge the gap then between what you're doing with the snow devices and outposts, which are intended to be
That's right.
permanent or more permanent infrastructure? And I know they're not identical, but you're starting to get kind of close.
It's, and that's intentional. In any, we have this continuum of capability from the very far, sort of ragged and rugged edge of where people need to be, all the way up through our regions. And along the way, you have devices like, or systems like Outposts, which are intended for long-term use in, I guess we can refer to as stable data center-like environments, where Outpost is an extension of the region. So when a customer installs an Outpost, they are essentially installing AWS equipment that is just like the equipment you'd find in our own data centers, that has a permanent connection back to our regions, and for all intent and purpose is expected to be connected to that region at all times, where you could have link instability for some period of time, like you can in any data center, where there'll be static stability during that short term, or intermittent connectivity issue. But it's intended to be there for a long time and be connected to the region all the time. Now, in the case of snow, that is, further out on the edge than you would expect to see most Outpost installations. And there, using the words I used a minute ago, we're expected to be in environments where connectivity to the cloud is denied, or that it's disrupted often, or that it's intermittent, or that it's limited. So in all of those cases, and they're all very unique depending on the use case. So in case of denied, we do a lot of really good work with the DoD. And in the case of DoD, as example, they may have a forward operating base where they will run AWS on clusters of snow devices. And those devices are, in fact, denied from getting back onto the network intentionally. However, they develop those applications on AWS. So if you're, the contractor or the government agency that is building those applications, they're actually building those applications in our top secret regions. Then they're deploying those applications straight onto snow devices and then deploying those snow devices out into the field. There, they collect the data, do all of the processing and analytics that are necessary for those environments. And if then important, those devices can be unplugged, put on the back of a Jeep, driven back to a plane, and where they're brought back, where the data is ingested into those top secret regions on behalf of those government agencies. And so we can actually sit there and have a series of these snow devices circling through those environments as necessary, or we can move the data back to AWS straight off of those devices if and when they're connected back to those regions. So there's a whole series of use cases like this.
So I think, and correct me if I'm wrong, in the early days of the snow devices, the rental or whatever, sort of the ephemeral usage of those was not very expensive, if not nothing. I think early on, Amazon was going to monetize that data as it came back in and became part of your footprint with AWS, right? But if these devices are out longer, being used for longer stints out in the field, have the economics or the way you bill for these changed or been modified over time?
Yeah, and it's a really good point. The original model that we had was based on renting the device, which we refer to as a job fee, which is a fairly modest fee. And for that fee, you would hold the device for some number of days, called 5 or 10 days. And then for anything over that 5 or 10 days, there would be a day-by-day charge until the device made it back. And that worked out really well for customers. When we started transforming the business from a purely data transfer business to an edge compute business, as I described a couple minutes ago, we actually evolved the pricing to be more cost considered for customers so that they didn't pay this daily additional fee, but instead would pay based on the capacity of the device for what they needed for their application. So look at it in some ways, much like EC2, you would rent an instance of a certain capacity, number of cores or vCPUs, and amount of memory and so on. And you would pay by the day or by the period. In the case of EC2, it's seconds and minutes. In the case of Snow, it's days, just based on logistics. And you would pay for those capabilities on a day-by-day basis. And it turns out that the pricing we put in place is incredibly amenable to customers and very competitive what they could do by buying hardware themselves and having that permanently on-prem or in their environment on an ongoing basis.
Okay, well, that's interesting and it makes sense. So for the hard drives and now the SSDs that you have in the small units, Snow Cone, Snowball, I imagine those are your higher volume units, and you've got many of them around and ready to go at any given time. With the edge infrastructure, especially with GPU in it, where things get a little more complex or at least more robust in the infrastructure that you have to deliver, how do you handle that from a supply standpoint to make sure that you've got enough of these around at any given time? Because I suppose customers are willing to accept some degree of weight based on the business benefit they get from something like this being relatively immediate, rather than building their own infrastructure. But it's not weeks, I don't think. So what happens? How do you manage that and keep the supply so that these things can bounce around whenever they're needed?
Well, Brian, one of the things that we're very good at Amazon is logistics.
I've heard that.
Our ability to put, if you would, analytics in place that can determine and predict what we're going to need where and when is pretty strong. I mean, one of the, just take a side trip for a second. One of the things that's really interesting about the devices, and we've seen others in the market find this an interesting idea as well based on their products, is by putting an e-ink label on the device and having that e-ink label be the shipping label. This was fairly novel and new when we did it. And our ability to have those devices essentially look like packing boxes is something that we understood how to do really well when we launched the product originally. And so the notion of us understanding the demand that is going to be generated for a particular device in a particular region is something of an active exercise for us every day, literally every day, and many times a day. So we, by and large, understand what our customers are going to want. We can predict what they're going to want. And is that prediction always accurate? It is not. There are times where, instead of having enough lead time to say, build a few more devices, we will need to shift where those devices come from because we have those devices located around the world. So customers may order a device from, our Ohio region, as we talked about earlier in this call, and it may turn out that we decide to vend that from our Virginia region instead. And so we have these capabilities because at the end of the day, besides being a cloud computing company, we also are a very strong logistics and transportation company.
Yeah, I can attest from the many boxes a day that show up on my doorstep that, whether it's toothpaste or snow cones, I trust that you can move things. I'm not so worried about that. But, I do just wonder as you get into more complexity with, like we keep talking about, with the edge infrastructure, with GPUs, and how do you continue to innovate there? And as that complexity increases, what does that do to the inventory management, supply chain management, and so on? And I guess while we're on the topic, everyone loves AWS because there are 8 million instances for everything you could possibly want, from compute to storage, now all these Graviton 3 instances and all the new storage stuff and you talked about FSX at the beginning, all the files stuff. There's so much going on, right? How do you filter, though, and predict what customers want in these edge infrastructure devices, which of those dozens or hundreds of services get integrated into something like the edge?
Yeah. It's a wonderful question. And it's part of the business planning that we do every year. And we ask ourselves this question every year because the answer always changes. Now, the good news is that the signal we get from our customers is the most helpful in making these decisions. We are often opinionated, as you know, about how things should happen. But that opinion is formed by and large from the input we get from our customers with some additional input that we provide saying, we hear this is what you need. This is what we think we heard. Are we right? And then we go off and we either build it or we already have built it and we will launch it and make people happy very quickly. So when it comes to what we land on the edge, we are listening very carefully to those that are building the applications in AWS, what they're using to build those applications, and what they need to deploy to the edge, whether that edge is in their own data center with Outpost, or whether that is on a Snowball sitting in, say, on an oil barge in the middle of the ocean, or again, because it's such a fun example is snow cones in space. So they will tell us that they need, as example, SageMaker Neo, which is a service that is part of our ML AI set of services. And it allows customers to run models that they developed on AWS at the edge, disconnected from AWS regions. So there's an example of a service that we brought out to our Snowballs early on. And, when we started, Snowballs consisted of EC2, S3, EBS, IAM for identity, and a few others, but that was the core of what we had, and that worked for most people. As we move forward, the ability to bring FSX out to that device, the ability to bring IoT Streetwise, or to bring Sitewise, or all of our other IoT capabilities to these devices. And in the case of Outpost, to be able to bring RDS and other services that people rely on to build their applications to these edge locations is something that we look at every quarter, and we engage our customers every day to understand what do they need next. How do we best meet the needs of their problem? Another great example is our bringing Greengrass onto all of these devices. Because customers have asked us, they say, well, we want to be able to run Lambda functions. We use Lambda functions in the region. We'd love to use that programming model at the edge. Can we do that? So with Greengrass, we're able to run their Lambda functions or their container applications, containerized applications on Outpost or on Snow. So this is how we evolve.
So I've seen Outposts up front at the summit last December or November, whenever it was, at the end of last year. You had these new 1 and 2U servers, but the very cloudy versions of them, right, where there's fewer ports and slots and everything, because it's very prescriptive what you're putting out there, right? It's you want Outpost, this is the 1U version, this is how it comes, and there may be a couple sizes by now, but quite prescriptive though in the hardware definition. With the Snow devices, same sort of thing. How much flexibility is there in that design? Like, as you go through this process, I'm just wondering about what do you have to create from a hardware standpoint, whether it's compute, storage, networking, whatever else, GPU, that you have to include in the hardware. How do you account for that in hardware design? Is it similar to what you're doing with Outposts? Are the nodes kind of similar, or is this totally bespoke?
Yeah, we share common designs, design principles, the actual designs, and in some cases, the physical hardware is shared between Snow, Outpost, and in-region data center hardware. So we try very hard to have as few SKUs as any company would, but we only limit that, based on having this analysis of what do customers really need, and can we build one SKU? And in some cases, we can. Often we can. And you may see a Snowball have more memory, more main memory than say an Outpost single 1U server, because it's going to be out in the field longer. And having more memory is going to be important as applications continue to grow and scale, where the customer may not want to return that Snowball. They may want to sit out there, and they would want their application redeployed onto that Snowball, which they can do. So they can, whatever application they're developing in AWS, as they evolve that application, which we want them to do actively, they then can deploy that updated AMI or application or Lambda function to the Snow. And by having more resources on that device, it'll be less frequent that they would say, "Hey, can you ship me the latest device because I need more horsepower?" And then we can easily do that, because we can actually do that rotation in real time, which we do today. So
Yeah,
we try really hard to have commonality to accelerate the rate of change we can bring to customers as they need it.
well, it's interesting to me how well you guys have honed in on this design, though, and understand, to your point, what customers want. Because when we talk about edge infrastructure, and what I would say, what we're talking about is like high value edge, so like the good stuff, not not the some of the more mundane edge use cases, but. Uh, it depends on who you talk to. If you go talk to Dell or HPE or Supermicro or Cisco, they're all going to have a little bit different story, a little bit different approach to what they want to do to help you meet these goals. And I think for a customer, it can be highly challenging to say, this is the answer, and then go deploy it in a couple hundred retail stores because you want to run, inferencing with customer behavior or whatever, or self-checkout or any of these popular use cases, to find out that maybe you didn't scope it well enough going in. And not that you're trying to solve that problem with these devices, but I just think with this edge infrastructure, there's so many questions about what do you want to do, how do you want to do it, and how much horsepower do you need. The customers are just really struggling to figure that out.
So that's a really good point. And if you have the following mental model, it becomes simpler with AWS. One, this is a holistic system that the customers are designing, architecting, and deploying. So they're not deploying hardware from one company and then software maybe from a third party, and maybe some of their own software onto this device. And I've been in this space for a long time, and a lot of folks that will be listening to this will have too. And when you're coordinating amongst a bunch of vendors, and that all has to land on some hardware that you have purchased, these are challenges that you have. Like the hardware needs to be maybe oversized so that it has great longevity in the field, and so on. With AWS, you're building the application in AWS. It is deployed to an AWS deployment environment. Whether that environment is a region, a local zone, an outpost, or a Snow, this is a holistic environment. So you're able, for instance, when you deploy onto a Snow, you're able to test that application in region on, if you would, a virtual Snow. So you know that my application will run on what I have in the field. And if you have gotten to the point where the capabilities that you built exceed the device, whether it's an Outpost server or a Snow device in the field, those devices are not purchased. They are part of the service that you acquire from AWS, that you essentially rent from AWS, and you can simply say, "Can you send me the next Snowball? Can you send me the one that has more capability?" And as I said earlier in our podcast, the pricing model that we use is on capability, on resources. Mm-hmm. So all you have to do is say, "I need a device with more resources," and we will provide that to you. Loading that new app, that new version on there, and away it will show up on your doorstep.
What are you doing from a visualization, or at least like a customer awareness notification process, to enable them to see hey, you're edging up on, either it's cores or GPU or storage, or, we're going to bounce into one of these things here, and, perhaps now's a good time to get that next order in. Is there something about that or in the dashboard to help customers visualize that?
Yeah, in the case of snow, we've launched a number of, if you would, device and fleet management capabilities, remote management capabilities, including the ability to monitor the devices. So if those devices are in a denied or disconnected environment, that monitoring still happens, but the reporting of that information goes to a local console. We have a sister product, if you would, called Ops Hub, which you can think of it as a disconnected AWS console for the edge.
Okay.
And that information can be viewed through that Ops Hub console. And all this information is accessible via API. So customers, if they had Snow as part of a larger deployment environment, say they're on an oil rig and they have a lot of different things going on, and they have one NOC or network operations center for that oil rig, they can plumb that maintenance data, that monitoring data into their NOC if they wanted to. So yeah, you can monitor the devices and figure out where you are. And as well, because you're able to develop these applications on AWS and run them, if you would, on a virtual device, you can have an understanding of the resources that you need to run that application as well. So you can approach it from both sides, from a development and deployment side and from an operations side.
So we've talked a lot about the more mainstream Snow offerings, but you also have effectively a container on a semi truck that can show up and do like 100 petabytes or something, right? In this, I'm not sure Snowmobile is like quite the right. Did you think about like Snow Yeti or something a little more grandiose? Because Snowmobile's not that big.
Listen, one of the hardest things in any product is getting its name right. It's really a tough thing. Just ask Corey Quinn; he'll tell you how tough naming is.
So tell me about this monster one. We've seen the demo at trade shows before, but what's going on there?
So the product that you're referring to, the service that you're referring to, is Snowmobile. And Snowmobile was launched, I'm going to get this slowly wrong, but it's 2017 to 2018. That was in response to customers that had, at the time, many petabytes of information, hundreds of petabytes of data that they wanted to move from on-prem. Often they were closing down data centers, and they wanted to move
consolidation.
Yeah. They wanted to move hundreds of petabytes, multi-petabytes to hundreds of petabytes, and in some cases exabytes of information from where they were to AWS. And so, in order to facilitate those customers' needs, we thought, well, we can ship them, hundreds of snowballs. That sounds logistically a little complicated. Or we can ship them one big one. And if we're going to ship them one big one, how do we get it there? Well, you put a lot of wheels underneath it, and you secure it, and you drive it there. And so that's where the genesis of that came from. Now, of course, as we see technology evolve, what could fit into a snowmobile 5 years ago can now fit into 10 snowballs. So as we keep moving forward, the volume of data changes, and so too does the capability of these devices. So we're always going to be looking at what's the most effective way of helping customers move that amount of data as quickly as possible. And to that end, a few months ago, we announced or launched a sister capability or feature for the Snow devices called Device Manager, which allows customers to go up to the console and say, hey, I'm looking to move, pick a number, 10 petabytes of data, and I need to move it in this amount of time. What do I do? And often the answer is, well, you can actually order, this, we'll call it 20 snowballs, and we will deliver 2 at a time, fill them up. And we will actually see that, those devices are filling up, and we will ship 2 more. And when those devices are full, magically 2 more devices show up until we know, based on ingesting the data, how much data you have left out there that you want to move. And we will, at that point, stop shipping you snows. And by the time you send us the last, 1 or 2 or 3 back, your job is done. So the logistics, again, of having to manage that process, we want to make it as simple as possible. So whether it's a snowmobile or whether it's a cycle of snowball edges or snow cones, we're going to help customers do that as effectively as possible.
Well, I understand the snowballs and the cones, but the semi truck doesn't show up with like a 200-foot long Ethernet cord dangling out the side that you drag through the window and plug into your network, right? So logistically, is it racks of gear that get offloaded and put into a data center, or how does that mechanically work?
So the snowmobile rolls up to your facility, and we've done in the case of snowmobile is usually some pre-planning, right? It's got to have a parking lot, it's got to have a space, it's got to have your proper networking connections and proper power connections, but nothing is offloaded from the truck. Essentially, you take and I'm simplifying for the purpose of this conversation, but you take a power cord and you take a networking cord and you connect them to your data center.
Ah, it does have a 200-foot long Ethernet cable. I was right. Okay.
No, I'm not sure about the length. I'm not. Yeah, I'd have to go do the math and figure it out. But yeah, there is a patch cord of sorts that is patched from your data center to the snowmobile for both power and networking. And then, just like a snowball device, you start up the transfer agent, and the data starts transferring from your data center right into the snowmobile.
And does any of this come with professional services? Because a lot of these engagements that you're describing, especially at scale, would typically have a services wrapper if it was, mainstream enterprise IT doing the transaction.
Yeah. So we aim to make this so simple. The term we often use is ridiculously simple, and we don't often achieve that, but we work towards that, and eventually we get there. That you don't need to bring in third parties. That being said, there's a lot of planning needs to be put in place to decommission a data center, as example. So a lot of times these large data transfer operations are facilitated by a vendor of choice by the customer, our own professional services organization, or one of our partners that will come in and plan the entire migration for our customers as part of a general migration plan. And in that case, yes, it is, for all intent and purpose, wrapped, but it's not so much that the snowmobile is wrapped, it's that the entire migration is planned and executed because it tends to be an involved exercise.
Right. Okay. So we've got the big scale, and we've talked about the ISS a couple times with the smallest scale device. We actually did a podcast with one of the scientists back, number 77, on Spaceborne 2, their supercomputer up there, and I was just at HP's event last week, and they're behind that, and they've got a little pod set up with the space station all set up the way it is for real, so you could walk in and kind of see, oh, that's kind of strange looking. Imagine running a data center in space. There's some challenges there. But the work they're doing up there with all the imaging and deep space learning and stuff is pretty cool. What is the role of your device that's gone up there? I've seen the video. We posted it on our own socials of unpacking and looking at, here it is, strapping it under a little elastic cord, plugging it in, and it looks like that was the extent of it, and off and running it is. But tell us more about what that's doing up there and the kind of work that's being enabled.
Yeah, so the application that Axiom and others wanted to be able to run and experiment with this this launch and this mission was the ability to collect photographs being taken on the station and run those photographs. So data collection, number one, data processing, to run those photographs through an ML model and to be able to do the analytics in real time on the station without having to move that volume of data back to Earth to do the analysis back on Earth and then report those findings back up to the space station so that they could re-aim the camera, retake the photographs, whatever the case may be. So in this particular case, it was a perfect use case for AWS's edge products, and in this particular case, Snowcone, where they were able to take those photographs, run ML, get the results in real time on the station, make local decisions without having to engage with mission control in any way, and continue to do that and demonstrate that they could run an off-the-shelf, ruggedized edge device like Snowcone on the station and do the job that they needed to do. And given that the applications were developed in AWS, those applications were deployed onto the device when it was delivered. And in fact, while the device was in orbit, we actually updated the device fully and changed the operating software and enabled them to do even more than they started to do when they first got the device during that mission. So it was a good example of truly deploying the cloud.
Well, yeah, but the device is so small, right? So what was shipped up there in terms of capacity or capabilities? Like what exactly did they get, or as close to it as you recall?
So it was a standard device. One of the things that we wanted to prove out is that what we provided them didn't need special cooling, special insulation, special shock vibration capability. It literally, the device you saw in that picture, other than being wrapped with, the special space tape, which forgive me for not knowing what the name of the tape is.
Yeah, the orange tape, though, we can all picture it.
Yes, exactly. Other than it being encased in the tape for various, just space reasons, that's smart. The device was a stock device. It went through a couple of months of testing to prove that it could deal with the shock of launch, to prove that it could deal with the environmentals of space. But we made the modifications. So when it went up there, when you go on our website and you look at a Snowcone SSD device, 14 terabytes of SSD, 4 vCores, and 8 gigs of memory, in 100 gigabit Ethernet networking capability. That's the device they got. And what they ran on it was this ability. It's an application that performed the ML AI analytics on the photographs, and that's what they had. So this device was shipped up as is with tape, and then the application they had written to do these analytics was run in the space station straight away. It required no IT administrator or sophisticated user to get it up and running.
No, it was simple. I saw that with my own eyes, so that was pretty cool. The storage inside, would you say 14 terabytes of flash in that particular?
14 terabytes of SSD. Yeah.
So I'm sort of torn on how to ask this. So when you're dealing with the Snow devices, they're not the primary storage resource typically, and that there may be some exceptions now. They're normally a copy of something that exists, right? So as you transport it, if it were to be lost or destroyed by some accident, it's not catastrophic. So you have to go back and redo the work and move things, and it's annoying, I would think, in most cases. How much do you worry about resiliency? So like in that 14 terabytes, is that 4 drives that are rated together for a little more data resiliency? So we're not going to get past the lost or destroyed. We can't do anything about that. But the data protection itself, as it moves around, how much do you worry about that?
Well, a couple of things there. One, the data is protected, so it's RAID protected. So that's the first thing. And to start off at the very beginning of the chain, something I want to make sure we always emphasize is that these devices are built such that they can be lost, and you never have to worry about the security of your data. All of the software that is loaded onto the device is encrypted and signed. At boot time, these devices are protected so that any software that's being loaded into the device is checked to be sure that it is the software that you sent up. Its signature is checked, and it's decrypted when it's brought into memory, and it's tamper resistant, so that if anybody tries to tamper with the device and open it up, we know automatically that that's happened, and you end up in a situation where the data is crypto shredded, so that you never have to worry about these devices getting lost and you're losing data.
I can already see the IT guy blowing up his own data because he's just so curious to tear that box open to see what's inside.
This might have happened. I cannot tell you whether it has or has not.
I'm certain it's happened because I know that's what would happen here. We get it in, and Kevin would start taking it apart after data was on there. Gosh. All right. Anyway, so security obviously is important.
It's so important. So once you get past the security piece, the data is protected. You use the word RAID, so we'll stick with that. It's a fine word to use in this case. Is RAID protected? And in the case of a snow cone, because that's what they used on the space station, customers do have the ability to move the data off of the snow cone into region using a service that runs on top of the snow called AWS Data Sync. And so Data Sync can be used to transfer any data that's on that device to AWS if you decide you don't want to send the device back because it's in an active application collecting data and analyzing that data. So that's one way of getting the data off the device. The other way is sending the device back to us. And if for some unforeseen reason the device is damaged or destroyed, then yes, you're right. The data that is on the device would no longer be accessible if it were not moved into region or copied off some other way before that happened.
So in the case of the ISS, is the cone that's up there, is it back? How long did it spend up there if it is home?
It's still above us.
Okay.
And it because of the success that we had in the mission, it was deemed a good idea to leave it there for future use.
Well, given you guys are charging by the day that thing's checked out of the library, that should be, it should make the quarter if that thing just floats around for the next couple of years.
This is a great partnership between us and Axiom, and I'm sure that everybody is happy with where we are.
I'm sure they are too. All right, well, this is great. I've really enjoyed this conversation. For anyone that wants to learn more about snow, where should they go to get that done?
Well, I would welcome them to go to our webpage and look up Snow family of products. And if you're interested in the snow cone, click on that. Snowball, click on that. And you can also, if you have an account, go to our console, go to our Snow console, and order one.
And if we order one, a snow cone, snowball, how soon would that get to you if you're really anxious and want to get going?
Well, usually we tell you on the page what the SLA is, given everything we talked about earlier. But you could expect to receive that within the week.
Okay, well, that's pretty quick. So there you go. We'll put a link to the Snow products in the description, so anyone that wants to check that out, we'll have that for you. And Wayne, this is great. I appreciate you taking the time.
It was a lot of fun to talk about the products, and it's a lot of fun to talk about what the teams do, and it makes me really proud of them. So thank you for that opportunity.
All right, thank you.
All right, have a good day.